Okay, so you should have your 9-2A worksheet in front of you, and then you should also have your graphing calculator to assist you in this. This is just a build off of what we already did before spring break, which was graph these things. But when we graph them, we can actually see the solutions to the actual equation. So it's a little funky. This is a quadratic equation. Okay, and the reason it's an equation and not a function is because it doesn't say y anymore, it says 0, where the y would usually go. So when we were graphing these before, this 0 was a y. Okay, so we're just going to bring in a y, and that really is telling us when y is 0, we're looking for where does this function cross the x-axis. It's really the x-intercepts rather than a y-intercept. So we've already talked about y-intercept is when you plug in 0 for x. Well, an x-intercept is when you plug in 0 for y. It's also how you can solve. So way back in chapter 8, we factored. We would solve this using ZPP and factoring. I'd have you set it to 0, we'd factor, and then we'd use ZPP. This is just a different way of coming up with the same solutions that we found when we factor. Okay, so this is solving by graphing. Right? And so what it entails is we graph the parabola and then we look at the picture and say where it crosses the x-axis. So everything's the same as before. It's just we're looking, our answer is going to be solutions just like it was for ZPP. We're going to put our solutions in those little squigglies. Okay, so get your calculator. I know it's been a while. I'll do a couple with you and then you'll have time in class to do it. You'll also be given another day to kind of clean up and make sure that you get it done. So the first thing we have to do is we have to calculate our x equals negative b, or opposite of b, over 2a. This is the only calculation we need. The graphing calculator will take care of all the rest of it so that we're perfect. Okay, so when we do this calculation, x equals opposite of b, my b value is negative 2. So my opposite of b would be positive 2 times 2 times my a value, which is 1. 2 times 1 is 2. X equals 2 over 2, or x equals 1. That is my axis of symmetry. Okay, I don't need you to put the axis of symmetry in today. We already did that, all those details. I do need my table of values. So now we're going to move over and we're going to use this information to get us our table of values. And I'm going to put that 1 into the middle of my table of values. And then I'm not going to calculate the other number. This is what we did in the beginning, remember? And we had to check them and make sure that they were right. We're going to let the calculator do the calculating for me. It will be in the table of values. So at this time, go ahead, take a few seconds to type that equation into your graphing calculators. Remember to use the xt theta n button for your variable. Just make sure you square. When you hit the squared button, it drops you back down. Minus 2 times the variable, and then plus 3. And go ahead and graph it, and you should see a parabola. Okay, and then what we can see now is just go to the table of values. So when I go to the table of values, I hit second graph, and I'm going to center my table of values around my vertex, which is 1, 2. I'm going to get my other order pair, so I'm just going to hit 1, 2 here. I'm going to put that on my grid. Actually, 1, 2 is here. Mine kind of skip spots. Kind of missing every other line there in my worksheet. And then 2, 3 is a point just below that. I'm just going to color coordinate them. So 2, 3 is 1 point to the right of my vertex. And 0, 3 is to the left of my vertex. And then I just need 2 more. I'm going to use negative 1, 6 to the left. 1, 2, 3, 4. I think that's right here. My picture is right. I feel like I'm missing some lines. And then also that matches negative 1, 6 is 3, 6. So remember, we don't have to find the y values because the calculator will do it for us. And it's just more accurate and it's not as frustrating. So now I can connect and extend my parabola. And I can see that this parabola doesn't have any solutions. Okay? It doesn't have an x-intercept. It's not crossing the x-axis, so we actually say no solution. Now, we didn't have that when we factored. When we would factor, had I given you some of these, this would be like one where it was like prime, like we can't factor it. Okay, no solution means it's a different whole set of solutions. So what we're saying is it doesn't cross the x-axis, we're good to go. So you're going to provide me all the wonderful work for x equals negative b over 2a. You're going to provide me then the table of values. You're going to graph it using that table of values with some accuracy. And then afterward, the only new thing we do here is we report where did it cross the x-axis. Okay, let's try it again. So let's try number 3 here. So for number 3, I'm going to go ahead and do x equals negative b over 2a. Now I notice my equation's a little funky. It doesn't equal 0. So if we're looking for where it crosses the x-axis, or in this case, the a-axis, we got to have it equal to 0, just like we did with ZPP. So before I do this calculation, I got to make sure everything's in the right order. I'm going to move that -1 over by adding 1, and now I got 0. And now if I have to graph it, we're just going to replace the 0 with a y, right? Just so we can graph all the y values will equal this to get a graph. We're still looking where it crosses the x-axis, but I need to put it in my equation, my calculator. But before I put it in my calculator, be careful of these a's. Your a's are really your x's, right? So if you wanted to change them to x's, you could. But your a value is really 1, your b value is -2, and your c value is 1. So when we do this calculation over here, x equals opposite of b, which is 2, over 2 times 1. I'm getting 1 again, right? X equals 2 over 2. X equals 1. So now I'm going to come over to make my table of values. Even though you're using the calculator, you are writing all of this down and keeping record of it. Okay, the fact that it's a whole number is good, so that I know that my vertex will show up in my table of values and it'll do the math for me. So I'm going to type this into my calculator now. Make sure you use that X, T, theta, N button for your variable. And hit graph. And now this time I see that it crosses the x-axis twice. Okay? And so let's see if we can figure that out. So now that I see the picture, I'm going to hit second graph to get to my table. I'm going to center that table, either arrow up or down, to get my vertex 1 in the picture, and 1 is at -2. So 1, -2 is going to be where I start graphing this, and my graph is just not showing that, so we're just going to make it up. Right there is about -2. Good news is we're moving up after that. Okay, so then 2 more ordered pairs around that 1, -2 are 0, -1. And 2, -1. So 0, -1 is right here, and 2, -1 is right here. And then the next 2 that I see are -2, 7. So I'm going to do -2, 7 next. No, I lied. Let's go to -1, 2. Sorry, -1 goes to 2. And then 3 also goes to 2. So -1 went to 2, and 3 went to 2. And if you notice, I do cross twice, but I don't know where I'm crossing. It didn't show up in my table. Notice anywhere in here, it didn't say 0 when the y value is 0. So what that means is it's just an icky point. And so what we're going to do here is we're just going to kind of state, well, where is it between, right? So we're going to say 2 solutions. There's a solution right on the x-axis right here. And then the other one is right here. Okay, and so I can't really state what they are. We can't just wing it and say that that's -1 and then that's 2. It's close to it. What we're going to say for this, for our 2 solutions, I'm going to get rid of my arrow here, just kind of squeeze it in. We're going to say 2 solutions. Okay, but I can't actually name them, but I'm going to describe them to you. One of them is between 0 and -1. And the other one is here, and that's between 2 and 3. It's 2 point something. Okay, we don't know what it is. We can't say 2.5, so we just say what it's between. That just gives us our accuracy to make sure that our graphs are okay. What I just did there when I talked about between This is that statement right here. If integral solutions can't be found, blah, 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 blah. Nope, we're not doing that. Okay, if it's not a whole number, you're just going to tell me what it's between. Okay, that's all that really crazy sentence is saying there. So we're just solving all the way through. Some of them will be nice. Some of them will be ugly. Let's go ahead and do, I'm going to go to number 2 just because I feel like I want to give you one that actually shows an actual solution. So let me just, that it's an actual number, and you'll see them show up in the actual graph. So if you guys want to go ahead and put that one into your calculator. Okay, and then it's already equal to 0. So we're going to go ahead and calculate our x equals negative b over 2a. Just because I need to know, is the vertex going to show up in that table of values, or do I have to calculate it a different way? Negative 6 over 2 times 1, x equals negative 6 over 2, x equals negative 3. So it's been nice. These are all whole numbers. Remember, we'd have to calculate the value if it wasn't a whole number, because the table of values only gives you whole number values. But since we've gotten whole numbers each time, when I go to make my table of values, I'm going to put my vertex in the middle. Okay, that's my middle point. It's in the middle of the graph, so I'm going to put it in the middle of the table. And I'm going to use my calculator's table feature to figure out what that is. When the vertex is at negative 3, my y value is at negative 1. So I can graph that. Negative 3, negative 1 is right below the x-axis. I need a couple more points. So to the left and to the right of that is negative 4, 0. And to the right of that is negative 2, 0. And so that's here, right on the x-axis, or in this case, the c-axis. And then I need 2 more points just to get that curvature. So I'm just going to go to negative 5, 3. And negative 5, 3's buddy that matches it on the other side is negative 1, 3. Every ordered pair has a matching buddy except for the vertex. So negative 5 up 3 and negative 1 up 3. So now I got my 5 points to connect and extend my parabola as best as I can. Okay, and then more importantly, I have my 2 solutions. My 2 solutions are these 2 x values or c values that when you plug them in for the variable, it'll give you 0, just like we did when we factored. And so my 2 solutions are negative 2 and negative 4. You don't give them as ordered pairs. It's sort of assumed that you're saying when the y value is 0. So you just give the x coordinate of when it equaled 0. So I showed you one of each. I showed you when you get a nice solution, what it looks like. I gave you one where you don't get a solution at all. And then I gave you one where you get a solution, but they're ugly. The only other option that we talked about in the notes is maybe only have one solution, and that would be when the vertex is sitting on the x-axis. So good luck. You guys can work on this. And then, like I said, you'll have some extra time to finish later.